In this video I'm going to be looking at the solution to question 7 from the January 2010 Edexcel FP1 paper. The topic of the question is coordinate systems. The question starts by giving us the general equation of the hyperbola xy equals c squared and a point in parametric form on that hyperbola, so the parameters ct and c over t, the coordinates x and y. We're asked then to find the equation, or to show that the equation of the tangent to the hyperbola at this point is given by t squared y plus x is equal to 2ct. And then, having found the actual tangent equation, we're asked to find particular points on the hyperbola for which those tangents will pass through a point given as 15c minus c. In other words, we need to find the parameter t and hence use that to work out the value of the coordinates. Well, all questions like this, where asked to find the equation of a tangent or a normal from that matter, use the fact that these are straight lines and therefore have equation y minus y1 is equal to gradient x minus x1, where the x1 and y1 is a given point on the curve, and m is the gradient either of the tangent or the normal. And that means that we need to find dy by dx. So for the tangent it will be dy by dx, and should we be asked for the normal it will be minus 1 over that value. So this involves then calculus. So taking our equation for the hyperbola xy is equal to c squared, we can write that as y is equal to c squared divided by x, or c squared x to the power minus 1, and hence dy by dx is equal to negative c squared over x squared. But we've got values for x and y, but x is equal to ct, and therefore at this particular point dy by dx is equal to minus c squared divided by c squared t squared, or in other words it's equal to negative 1 over t squared. Having found the gradient then of the tangent, we can say that the equation of the tangent is given by our general equation of the straight line y minus y1, where y1 is c over t, is equal to negative 1 over t squared, and then x minus ct. It's then quite a simple thing to do to multiply through this equation by t squared to give us t squared y minus ct is equal to negative x plus ct, and then finally to give us the equation that we want, therefore t squared y plus x is equal to 2ct. The mark allocation for that, there are 4 marks for this part of the question. There's a B1 mark for getting to dy by dx is negative c squared over x squared, and then M1 for calculating the gradient correctly at the given point, and then M1 and A1 for finally getting to the given solution. Now, because the solution is given in the question, that you would only get the mark, this final mark, if if your working is fully correct. So it's what's called correct solution only mark. Before I go on to the second part of the question, I'd just like to consider this calculation of dy by dx in other ways. The method I've shown is probably what most of you may use. However, some of you may have met the idea of parametric differentiation, in which case we can use the parameters x is equal to ct and y is equal to c over t to give the derivative dx by dt is equal to c, and dy by dt is equal to negative c over t squared, and therefore dividing these we get that dy by dx is equal to negative 1 over t squared. An alternative way is if you have met implicit differentiation, then we can take the equation t squared y plus x is equal to 2ct and differentiate this. Sorry, I beg your pardon, that's the equation of the tangent. We need to take the equation xy is equal to c squared and differentiate that so that this is a product, so that we get y plus then x multiplied by dy by dx is equal to the derivative of c squared, which is 0. And then that gives us that dy by dx is equal to negative y over x, and that's equal to negative 1 over t squared. So that gives two alternative ways of producing that the gradient of this tangent is equal to negative 1 over t squared. And using those two, we get to the point then, as before, the rest of the solution is no different to what I've just looked at, and with those both lead then to the fact that the equation of the tangent is given by t squared plus x, so t squared y plus x is equal to 2ct. In part B of the question, we're given that two tangents meet at this point 15c and minus c. So that means that these values of x and y must be solutions to the tangent equations. So using those values, the fact that x is equal to 15c and y is equal to negative c in the equation of the tangent gives us that negative c multiplied by t squared plus 15c is equal to 2ct. We can cancel through that by c and then rearrange it to give a quadratic t squared plus 2t minus 15 is equal to 0. And that factorizes t plus 5 and t minus 3 is equal to 0. Or in other words, t is equal to negative 5 or t is equal to 3. So that gives us two values of t to substitute into our parametric point P, which is equal to ct c over t. These are points on the hyperbola now. So the 2 points are A, which are negative 5c and negative c over 5, that's using t equal to -5, or B, 3c and c over 3. The marking for this part of the question was a method mark and an accuracy mark to obtain that quadratic, method and accuracy mark to give the two values of t, and then finally a single mark, a mark, for getting both of the points. There are other videos looking at questions from FP1 and indeed from other modules, which you can find on www.furthermaths.org.uk.